Hello everyone. In the last videos, we derived expression for depression in non-uniform bending. Here in this video, we are going to derive expression for elevation in uniform bending. Bending is said to be uniform when all points in the neutral axis have same radius of curvature. A beam loaded symmetrically at its ends shows uniform bending. Consider a beam which is supported on two knife edges A and B. The distance between the two knife edges B, L. The beams are loaded with weight W at the points C and D. The loads are kept at an equidistance beyond the knife edge, that is CA equal to P, likewise BD is equal to P. Because of this load at this ends, the beam starts bending and we can see elevation at the midpoint. Let this elevation be delta and we are going to derive expression for this elevation. So EF is the elevation and we are going to derive expression for this. If we take this portion of the beam, the external force acting vertically downwards is mg and the reaction on the knife edge is acting vertically upwards and it is also mg. These forces constitute a couple and the moment of this bending couple is mg into P. We have derived earlier the internal bending moment of the beam. And it is equal to Yig by R. At equilibrium, the external bending moment and the internal bending moment are equal. So, the bending beam is like an arc of a circle having radius of curvature r. From the property of circle, AF into FB is equal to EF into FD. Where AF is L by 2 and FB is L by 2. EF we know it is delta and FD is 2R minus delta. So multiplying we get L square by 4 equal to 2R delta minus delta square. We know that the elevation delta is very small. So squaring that the term will be neglected because it is very small. So we get L square by 4 is equal to 2R delta. Since delta square is neglected. So from this we can get R, that is L square by 8 delta is equal to R. So this is equation number 1. This is equation number 2. Substituting second in first, we get mgp equal to yig by L square by 8 delta, which is equal to yig by L square into 8 delta. So rearranging, we get delta is equal to L square mgp by 8 yig. So with this we can get the elevation of the bending beam. We can also find the Young's modulus of the material once we know the elevation of the beam. That is y equal to L square mg p by 8 delta ig. Now we have two conditions. That is case 1, when the beam is having a rectangular cross section. For rectangular cross section, we know Ig is equal to BDQ by 12. So substituting this in equation 4, we get y equal to L square mg p by 8 delta b dq by 12, or 12 L square mg p by 8 delta b dq. The next case is for circular cross section. Here Ig is equal to pi r power 4 by 4. So substituting this in equation 4, we get y equal to L square mg p by 8 delta pi r power 4 by 4, which is equal to L square mg p by 2 delta pi r power 4. So from experiment we can find the elevation of the beam, and using this we can find the Young's modulus of the material. Thank you.